All right, a little bit about John. Has almost 20 years of experience as a software developer, and cares about the quality of software and the value that it provides. He does test-driven development, pair and mob programming, continuously integrating code changes and continuously delivering value to customers. When he's not developing software professionally, he does some game and mobile development, works on robotics projects while trying not to bring about the robot apocalypse. He folds some origami for friends and strangers, or spends time with his wife and 3 children. With that, hand it over to you, John.
Awesome. Thank you, Steve. Can everybody hear me okay?
Yeah.
Okay. Did I get frozen?
Your video went away for a second, but it came back now.
Okay. Did you hear that? Did you hear me do all that talking?
Yes. Yes, all the intro and everything, yeah.
Okay, great.
I did it. Sure. Hopefully everybody else did.
Okay.
If it was only me, it was lovely. Thank you.
All right.
Okay, let me see. I'm going to share that screen. I'm going to bring this back. Okay. Well, welcome everyone. Thank you, Steve, for that intro. And thanks to all the organizers for inviting me to come and talk for a few minutes. Welcome everybody to this presentation, what modern software development should look like. As Steve said, I am John. I have to apologize. I have a little bit of a cold today, so hopefully my voice will hold out. But if I start hacking and coughing a lot, I'll try to mute first. But if I miss by a second, I apologize in advance. Okay, a little bit about me, just to start off. I work for a company called Samcart. They're based in Texas, technically, though pretty much everybody's remote. That we do online e-commerce, single page checkout experience stuff for like influencers and stuff. Anyway, if that sounds interesting to you, feel free to talk to me about that if you want. I'm the chief architect there, for what that's worth. If you do want to talk to me about any of that or about the presentation or anything, I have my email address there and my LinkedIn profile if you want to connect with me or whatever. I put a couple other links on here that I thought might be useful. Obviously, everyone is attending this meetup, which I fully support and endorse. I also run another meetup. I co-organize it with a friend and former coworker of mine. It's called the Utah Software Craftsmanship Group. So I put a link to our website there. If you want a group of people to talk to about things like test-driven development and pair programming and continuous delivery and stuff like that, it's a good group. We like talking about stuff like that. We meet on the first Wednesday of every month. We're also meeting virtually. We have a Slack group if you just want to join that and lurk. That's totally cool. I also put a link to my personal website. Mostly it's weird ASCII/retro video games and my blog, but if you want to check it out, you can. I also put a link to another website. I have a large collection of software development related quotes, and so I made a website to gather all of those quotes and make them easier to access. It's called megamanquotes.com. I'm gonna be referencing quotes that are there a lot in the presentation. And so if you want to go there to see those quotes or share them with other people, you can. And then there are a bunch of other quotes too. If you just want to go and find cool quotes about software development. And then finally, I put a link to the slides. That's also what the QR code goes to. There's a link to these slides. If you want to go and check out the slides later. I'll post this link in the chat too, if you don't want to type that tiny URL, whatever that is. Also, one little disclaimer. I know this is the SLC.NET user group. I'm not actually going to talk about like C# or .NET or anything really in this presentation, though I have been a C# developer for like 20 years. So hopefully that gives me a little bit of street cred, and hopefully you forgive me that solicits a little bit of forgiveness for me not actually talking about C# or .NET in this presentation. Okay, with that, I want to start by talking a little bit about opinions and brains, both actually. So in software development, there's a lot of different ways we can do software development and a lot of different contexts in which we do software development. And because there are so many different practices we can do in different contexts in which we can use those practices, it gets really hard to have clear, definitive data about like, oh, well, this practice is always better, or in this context, this practice is always better, because it's really hard to like isolate things. That's both great and terrible. It's great for me as a presenter because I can just get up and be like, oh, hey, this is what I think. And, you know, there's no data to contradict me. It's terrible for you as attendees because, you know, then it's like, oh, well, John's just saying this stuff. What evidence does he have to back any of this up? And it's true, I don't have a lot of evidence. There are some things that have more science and data behind them that I'm going to talk about. I'll try to remember to point those out when we get to them. There are a few of them, but a lot of it does come down to what feels like, at least anyway, basically just opinion. And so I'm going to lean on my personal experiences. I'm also going to lean on the advice of what I call industry experts. That's why we're going to talk about a bunch of quotes and things like that. I'm going to do a psychological manipulation technique called appeal to authority. So I'm going to appeal to the authority of someone who I believe is an industry expert in an effort to convince you. So I figure since I'm going to do psychological manipulation, might as well at least, you know, tell you about it beforehand, right? But it turns out, though, with the whole data thing, it maybe doesn't really matter anyway, because we as humans, we have our brains, and our brains are super awesome at pattern matching. Our brains love to do pattern matching. They're really good at it. In fact, they're so good at it that sometimes they even see patterns when they don't exist. And sometimes they will go to great lengths to ignore data and other facts that contradict patterns that we've already recognized. Or you could also say opinions that we've already formed. That's a type of pattern, right? And so it turns out like we don't really want to hear other people's opinions. Really, what we want to hear is our own opinion coming out of someone else's mouth. Because if someone else expresses the same opinion that we already have, then we feel more validated in our own opinion. That's just how our brains work, right? And so what happens, though, is when someone expresses an opinion that is different than yours, your brain's first reaction is typically to reject it and say, nope, that does not match the pattern that I already know, the opinion that I already have, and so therefore I will reject it. And sometimes our brains react so violently, like reject data so violently, that we get upset and we get offended, right? So there will probably be some things in this presentation that I talk about that you will not agree with. And maybe you will not agree with them so strongly that you get offended by them. But as I was preparing for this presentation, I was looking through quotes and things, and I found this great one from George Bernard Shaw. He said, "The secret to success is to offend the greatest number of people." So my goal in this presentation is to offend everyone by the end. So just be prepared for that. Something that I say, there's at least one thing that I'm going to say that you're going to disagree with, and it may even offend you. And that's my goal. If I offend everyone, then this presentation will have been successful. So just be prepared for that. Be prepared for that. Okay, as I was preparing for this presentation, I started by just making a really big list of what I thought modern software development should look like, right? Like in modern software development, here's a thing that we should do, or here's a thing that we should not do. Like I started with a big list, right? And it's not necessarily a comprehensive list. There could be other things on here. So if I left out your favorite thing That doesn't necessarily mean that I think that it's terrible or anything like that. But I ended up with this great big list. It was, I don't know, like 30 things long or something. Some of the things I consolidated, a few of them I took off, but I still ended up with a relatively big list. And I thought I could just go through this giant list of things in a random order, but that didn't seem like it would be very easy for people to absorb the information. So I put it into groups. I put the things into groups. I ended up with 5 groups. There's nothing magical about these particular 5 groups. There's also nothing magical about, like, we could reclassify these things and put them into 4 groups or 6 groups or something like that. So there's nothing magical about necessarily the groups themselves, other than I put things in groups to help make it easier to think about the things on the list and reason about them. There's also nothing magical about the order of the groups or necessarily the order of the things in the groups. But we're going to go through these 5 groups. The first one we're going to talk about is process. And when I say process, I'm talking about the steps that we go through in deciding what feature to build and how that feature should work, and the technical implementation of that feature and how we're going to get that feature to our customers, to the people who are going to use our software. That's kind of the stuff that I'm talking about with process. And I mentioned that it's my goal to offend everyone. So I'm going to try to start off strong. And the first thing we're going to talk about what I think modern software development should look like. I think it should not look like Scrum. Did I offend everyone yet? I'm trying to start off strong here. I should clarify this. I think modern software development should not look like only Scrum. I also think that modern software development should not have Scrum as an ideal end state. Maybe it could be a starting point, but I don't think modern software development should hold up Scrum as an ideal. This is what we should do, and this is our goal. And once we've reached there, we're done. We don't need to improve anymore. I have a whole other presentation that talks about not that Scrum is necessarily bad. There are a lot of good things, but there are also some things in Scrum that encourage certain behaviors that result in negative consequences. I have another presentation where we can talk all about that. If you want to talk to me about that sometime, we can. And from this, for the purposes of this presentation, at least anyway, I think maybe one of the more important reasons why modern software development shouldn't look like Scrum, or at least it's not only Scrum, is because Scrum doesn't say anything about technical practices. In software development, we have a lot of technical practices, and Scrum doesn't say anything about that. There are some other methodologies that do, but Scrum is not one of them. Which brings us to our first Mega Man quote that I'm going to share. It's by Ron Jeffries. If you're not familiar with Ron Jeffries, he's one of the original Agile Manifesto authors. He was one of the early extreme programming guys, stuff like that. He's very, very cool, very smart. This quote comes from his book, The Nature of Software Development. He says, Scrum does not explicitly include technical practices such as acceptance test-driven development, refactoring, and so on. I'm here to tell you, excuse me, I'm here to tell you that to prosper, you'll need to add those practices to your Scrum projects. What I would recommend, maybe Scrum could be a starting point. It doesn't have to be, but it could be. But what I would recommend is that for modern software development teams, develop their own process. Again, could be use Scrum as a starting point, but not necessarily as an ending point. Excuse me. As teams are finding their own process, what works for them in their own context, I would recommend consulting the Agile Manifesto. I mentioned it just briefly. For those who aren't familiar with it, the Agile Manifesto came about in 2001. In the mid to late 90s, in vogue was stereotypical waterfall. Obviously not everywhere, but in a lot of places. And so a lot of big design up front, a lot of large batch size, infrequent deployment, excuse me, isolated functions. So the people designing the software didn't necessarily talk to the people actually implementing it, and the people implementing it didn't necessarily talk to the people testing it, things like that. And there's a group of people who got together and said, hey, this maybe isn't the best way to develop software, and how could we develop software better? This is actually one of the inspirations for this presentation. The Agile Manifesto, it's actually quite short. If you haven't ever read it before, I'd recommend you go and do so. It has 4 values and 12, I don't have that many fingers, but 12 principles. I'm going to read this part with values because it's pretty short. It says, we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value, and then these are the 4 values: individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. So it's not saying that there's no value in, for example, having processes about how we build our software, or using tools to help us keep track of of where things are at in a certain process or something like that. Just that there is more value in the people actually doing the work and how those people are interacting than there is in exactly what process we're using and exactly which tools we're using. Similarly, you know, the last one, it's not that there's no value in having a plan, but there's a lot more value in being able to respond to changes than there is in having and following a plan. So these are the 4 Agile Manifesto values. Then these are pretty high level, and also there's only one that directly talks about software, something technical, and so there are 12 principles. I'm not gonna read all of them. I would recommend you go and read them all. These are a little bit more concrete. There's some of these that if you read them, you'll probably be like, oh, I see how that translates into a specific practice that I'm familiar with. For example, on the left, the 4th one down, it says business people and developers must work together daily throughout the project. You can see how that could translate into something like a daily stand-up. That would be one way that business people and developers could work together, right? Similarly, on the right, the last one, at regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. You could see how that could translate into something like a retrospective. A retrospective is one way for a team to reflect on how to become more effective. So if you haven't ever looked through these before, I would recommend you do it. And in modern software development, I think that teams, as they are finding their own best way to work, that they should consult these values and these principles as a guide, right? That they should incorporate these values and principles in the way that they work. In addition to Agile software development, I also think that modern software development should include components from lean software development. Now, I don't know if everyone here is familiar with Agile software development, but in my experience, most people have had some exposure, at least anyway, to the idea of Agile software development, but a lot fewer people have had exposure to the idea of lean software development. So just to talk a little bit about lean software development, for those who maybe are a little less familiar with it, some people lump it as under the general umbrella of Agile software development. I kind of consider it as sort of like a cousin, because it didn't come from the same roots necessarily. It comes from lean manufacturing, and then people have adapted, the ideas from lean manufacturing to software development. So some things translate really well, other things don't translate as well. But some of the key tenets of lean software development are things like eliminating waste. So of all the things that we do while we're working on some new piece of software, let's say, which of those things actually contribute to getting that software done and providing value? And which things don't actually contribute? If there's things that don't actually contribute to that, maybe don't do them, or do them less, at least, right? Try to focus on the things that are actually providing working software that provides value to our end users. So eliminating waste is one of the tenets. Eliminating waste. Limiting work in process. So this one is focusing more on, rather than having a bunch of things in process all at once, maybe having fewer things actually, being worked on, and work on getting those things done before we start new things, right? So having that number of things that we're working on at one time be smaller, maybe even one. I know that sounds radical, doesn't it? The third one on this list is favoring flow efficiency over resource efficiency. So we can have different types of efficiency. People use the term efficient a lot. Efficient with regards to what? So like, for example, in the space of algorithms, we could have a sorting algorithm that is efficient with regards to memory, but maybe not efficient with regards to CPU utilization, for example, right? And vice versa, we could have a different sorting algorithm that is efficient with regards to CPU, but not to memory, right? It uses more memory, but it's faster, for example. In lean software development, we have these two types of efficiencies that are oftentimes competing, but not always. I'm going to start by talking about the second one, the resource efficient. So when we're developing software, if we focus on resource efficiency, in this context, the resource, I don't like calling people resources, but in this case they are. The resource is the people doing the work, the people building the software. And so if you're being resource efficient, according to lean software development, then you're focusing on making sure that the people doing the work are busy. Like they always have work to do, which sounds like a great thing, right? We don't want people just sitting around doing nothing. That doesn't sound like a great way to get software done. But let's contrast that with flow efficiency. So flow efficiency, rather than focusing on the people, focuses on the work being done. So we get into the actual definition of flow efficiency, but the way you can think of it is, are things getting done? Are things getting worked on? Or are things sitting idle, waiting to be worked on for a long time, right? That's really the heart of flow efficiency is the work to be done? Is it sitting around waiting to get work done? And in lean software development, we want both flow efficiency and resource efficiency. So we want things to be getting done, flow efficiency, and resource efficiency, people being busy doing things. But if we have to choose, then we choose flow efficiency over resource efficiency. So said another way, in lean software development, we favor things getting done over people being busy. And if you think about it, it makes sense, right? At the extremes, for resource efficiency, if you focus only on resource efficiency to the exclusion of all else, everyone's busy all the time, not necessarily anything's getting done. In that case, everyone's busy, but you're not actually providing any value, right? You don't want that. On the other extreme of optimizing for flow efficiency and nothing else, at least in that case, things are getting done. You're providing things of value, right? Maybe not everybody's busy. Maybe only one person is busy, but at least things are getting done. So in lean software development, we favor flow efficiency over resource efficiency. We try to get them both, but if we have to choose one, we choose flow efficiency. Another way to encapsulate both flow efficiency over resource efficiency and limiting work in process is this phrase, stop starting, start finishing. So the idea of, we don't want to start a lot of things, we want to focus on getting things done rather than having a bunch of things in process. Okay, so I think modern software development should include aspects of lean software development as teams are finding their own process that works for them. Here's another quote for us. This one comes from Jez Humble. He's one of the co-authors of the book Continuous Delivery. And he says, one of the key things that people miss is continuous delivery is about optimizing for cycle time. So here he uses the term cycle time. We'll talk about cycle time in a little bit more in a minute. But you can think of, for the purposes here, you can think of cycle time. Cycle time is how long it takes something to get done from the time you start it to the time it's actually done. So you can think, we can substitute here flow efficiency. Flow efficiency is similar to, it's related to cycle time. It's not exactly the same thing, but it's related. So delivery is about optimizing for cycle time, or you can think about flow efficiency, because we were just talking about that. When you optimize for cycle time, or again, flow efficiency, you do not optimize for utilization. And here he's talking about utilization of people. Your utilization goes down. Your people are not 100% utilized anymore. So this is the quote encapsulates that whole idea of favoring flow efficiency over resource efficiency. And he says, hey, if you're optimizing for flow efficiency, or here he's calling it cycle time, people aren't going to be busy 100% of the time, and that's okay. In lean software development, we also talk that the first tenet that I mentioned is eliminating waste, eliminating things that don't actually contribute to getting working software that provides value for people. I haven't been sufficiently offensive for a couple slides here, so I gotta get in my offensive stuff so that everyone can be offended by the end. I'm going to talk about one of those things that maybe we shouldn't do as much or even at all, which is estimates. There's a whole movement called no estimates. It was popularized by a guy named Woody Zool that was started by somebody else. He actually kind of regrets that the hashtag turned into no estimates. He likes to say like more. Well, actually, let's read a quote here from Woody Zool. He said, "It's important to ask ourselves questions such as, do we really need estimates? Are they really that important? Are there options? Are there other ways to do things? Are there better ways to do things?" So what Woody says is not that we should never, ever do estimates and that they're 100% always evil. But sometimes we get really fixated on providing estimates and put a lot of time and effort into them, when almost always we know that they're going to be wrong, right? We give dates and estimates and timelines and roadmaps, and they almost always change, right? So if we know they're going to change anyway, then maybe let's not put more effort into them than we actually need to. Another Mega Man quote about estimates. This one comes from Ron Jeffries. Again, we already talked about him a minute ago. Estimates remain a controversial topic in software development today. Many people think that estimates and detailed planning are important. Certainly, some companies want these things badly, and that may be enough to cause us to do them. Unfortunately, badly is almost always how we do with estimates. For teams in flight, estimation is at most an internal matter and may well be almost entirely waste. Okay, so hopefully hopefully I got a fair number of people offended so far with my discussion of estimates, and that I don't think that that modern software development should include them for the most part. Not that you should never do them, but most of the time you shouldn't do them. You may be thinking to yourself, okay, well, what should we do instead then? For that, I will also go to Ron Jeffries, another quote. And he says, "We do best not when we predict when we'll be done, estimate, but rather when we choose when to be done and then ensure that we put the best features in by that date." So the deadline's going to come no matter what. So rather than spending a bunch of time and effort trying to figure out if we can cram all this stuff in by the deadline, which we know isn't going to happen anyway because all of our estimates are terrible, rather focus on making sure that the best, most important, most valuable features are in there first. And that way you have the best chance of getting the most value by whatever deadline you have. If you're interested in that, go read his book. He has a lot more about that. Okay, new topic. This one's probably not going to be wildly offensive. I apologize in advance, but I think in modern software development, we should talk to our end users frequently. Ideally, the people who are actually going to use our software, we should talk to them. If you're working on internal software, that might be easy. Maybe it's you that's the end user, in which case it's very easy. If it's internal software, maybe you could go walk to somebody else's desk. If we're talking about like SaaS software or something like that, oh, that's kind of redundant, isn't it? Because one of the S's in SaaS is software. But anyway, it might be harder to actually talk with those customers, but you can usually still do it. You can do customer interviews. At the very least, usually you can do some kind of analytics to know what your customers are doing, right? Because in the end, we're making our software for people to use to solve their problems. And if they don't use it, it can't solve their problems. And if they do use it and it doesn't actually solve their problems, then we've failed, right? And we need to know that. And one of the best ways to know that is to actually talk to the people who are using it. This is one example of a larger theme of short feedback loops. I think modern software development should have a lot of short feedback loops. Now, one example is talking to our customers. Hey, I wrote this code and built this feature to solve this problem and provide this value to you. Did it actually do it in the way that you wanted, right? In a way that's valuable to you. That's a form of feedback loop. There are other types as well. For example, I just wrote this line of code. Does it actually do the thing that I want it to do? That's another type of feedback loop, right? In modern software development, we should have a lot of these short feedback loops. When there's a lot of time between when we take an action and when we see the consequences of that action, it makes it really hard to learn. So when we have a short feedback loop, a short amount of time between when you do something and when we see the actions of it, it enables learning. It enables us to learn a lot more easily, which leads me to my next thing. In modern software development, we should have continuous learning, partly from these short feedback loops, but there are other types of learning too. You can, there's the learning about the products that we're making and how we're making them. You could also put in here learning about better ways to develop software, increasing our skills with particular tools or techniques or other things like that. When we're learning continuously, so learning continuously is important, but if all we're doing is gathering information and not changing our behavior, then it's not very helpful. Which leads me to my next topic. Modern software development should also have continuous improvement. So not just are we getting feedback, are we learning new things, but are we actually changing our behavior based on that learning? With modern software development, we should have mechanisms built in place to promote continuous learning and continuous improvement. One of the ways we can do that, that I think should be part of modern software development, is regular retrospectives. This is one of the things from Scrum that I like. If you were offended by that, this is one of the things that I think is great from Scrum, but it's not exclusive to Scrum. Let's read a quote. So this is going back to Woody's rule. This is about retrospectives, though, as opposed to estimates. Woody said, if you adopt only one agile practice, let it be retrospectives. Everything else will follow. And if you think about it, if you have a way to evaluate what happened and adjust based on it, you could actually come up with all the other agile principles and lean software development principles, any of these other practices and things. You could come up with those just based on trying things and adjusting based on what you learn, right? As long as you have that sort of mechanism in place. Obviously, if you can implement some of those things without having to go through that whole learning process, that will put you further along the path more quickly, but you could get everything you need just from retrospectives. And so to finish up with our group of process related things that we're going to talk about, we're going to end with one last one. This one, it comes from Ron Jeffries again. He said, try to have too little framework. In this case, I would use the word framework and process interchangeably, the way we're using here. Try to have too little, not too much, don't even have enough. In modern software development, we're working with real people that usually have good intentions and are usually trying to do the right thing. And if we put in too much process, too many rules, too many ways to handle exceptions and odd cases and things like that, we're just going to slow everyone down. And it's especially for us as software developers, we like to work with we work with computers, and we deal in all those exceptions and things like that. It's in fact it's a good thing, right, to like handle every single case and things like that. But with people, that doesn't work so well. So don't treat people like you treat computers. All right, so that's our first group, is process. The next group of things that I wanted to talk about is related to teams. I haven't been wildly offensive the last couple slides, so let's go for some more offense here. I don't know how many people this will get, but maybe it'll get a few people. I think in modern software development, things should be owned by teams and not individuals. In my experience, I found that when we've probably all at least heard of the experience, if we haven't lived through it ourselves, of there's this one section of the code that there's only this one person who knows, and anytime that section of code has to change, it has to go through that person. And if that person ever, some people say, got hit by a bus, other people say won the lottery. If that person was ever not available, then that code couldn't change. And that's not a good way to live. It's not a good way to develop software. In my experience, when things have been owned by teams, it provides better redundancy. It also provides better solutions when more than one person is looking at it. So I think in modern software development, things should be owned by teams, not individuals. In order to do that, the best way that I've seen to do that is to use cross-functional teams. Cross-functional sometimes gets a little overused. You'll go and talk to somebody and they'll be like, "Oh yeah, we have 12 developers on our team. It's cross-functional." It's like, wait, do you know what cross-functional means? When I use the term cross-functional, what I mean is everyone who is needed in order to build a feature and get it into the hands of users is on the team. So you have people who can help decide what to build, how it should work, the actual technical implementation of it, do whatever quality assurance that you need to make sure that it's ready to be seen by users, actually deploying it, operationalizing it, monitoring it, all of that is on one team. That's a cross-functional team in my mind. So here's a quote from Jeff Patton. He's big in the product management world. This is from his book User Story Mapping. He says, handing off all the details about the story. So here, his book is about user story mapping. So here he's using the term story, but we could interchange this with the idea of any piece of work that we're doing. Handing off all the details about a story or some piece of work that we're going to implement to someone else to build doesn't work. Don't do that. So here he's talking specifically about the part of the process where there's someone who's deciding what to do and how it should work, and there's another group that's actually doing the implementation of it. He's talking about not having separation there, but we can increase the scope of that to the entire process, right? We shouldn't have these silos anywhere along that process. Might be saying to yourself, well, that sounds great. How do we do that? If you were thinking that, thank you for asking. To do that, rather than the work that teams have, the ownership that they have should be vertically sliced rather than horizontally sliced. What do I mean by that? Typically in software development, we'll have different, sometimes we call them layers or tiers, or we make up some other cool word for them like that. We have different parts of our software, and oftentimes those different parts are aligned to different areas of expertise. So for example, this isn't the only example, but it's a common example. We'll have like a front end part of our product or system we'll have a back-end part of our product or system, and we'll have some data access part. You know, this is just an example. These could be different or something. You know, they could be other things as well. And what we tend to do is to form our teams this way around areas of expertise. Excuse me. We have all of the front-end people work together on a team, and we have all the back-end people work together on a team. We have the data access people work together on a team. And we group by areas. We group the work horizontally by area of expertise in order to make it so that we can have, but you know, in this model, the front-end team can't complete a feature on their own. They can't complete a feature without talking, because we'll have to have some sort of back-end implementation, right? To retrieve data, to store data, to do something, right? So the front-end team can't implement a feature by themselves. The back-end team can't implement a feature by themselves. The data access team can't implement a feature just by themselves. So the way you get teams that can implement an entire feature by themselves is to group the work vertically rather than horizontally. So you have a team that has people who have front-end expertise. You have and on that same team, you also have people who have back-end expertise. And on that same team, you also have people who have data access expertise, or whatever layers you happen to talk about, right? This would I'm talking technical here, but this would also include things like quality assurance, product management, user experience design, things like that. If those are necessary in order to complete a feature, those people would also be on a team. So in modern software development, I think we should not have these horizontal teams, front-end teams, back-end teams, database teams, whatever. We should have vertically aligned teams. Now, I do have a small caveat, like once organizations get to a certain size, you might have a support team that, you know, builds front-end components for other teams to use or things like that. But that's a different situation. For the teams that are actually building end-user facing features, I think those should be vertical teams. Now, if you have all those people on the same team, but they still do their work separately, then you really still have the same problem. You've just divided it up into a bunch of small problems instead of one big problem. So in modern software development, I think teams should work collaboratively. So those people who are all working together, who collectively all have the skills necessary to develop and deliver a complete feature, those people need to actually work together. And I haven't been offensive for a couple slides, so I better get back to it. I think in modern software development, the best way to do that is with pair or mob programming. I think most software should be developed using pair or mob programming. I didn't want to be super negative here, but I think most software should not be developed using an asynchronous pull request model. In my experience, this method of developing software compared to an asynchronous pull request model or a solo coding model, this just results in better software that is more maintainable and is higher quality. That's been my experience, at least anyway. I told you I was going to do that appeal to authority, right? That's what I'm going to do now. Going to appeal to authority on pair and mob programming. Chet Hendrickson, he was not one of the Agile Manifesto signers, but he's buddies with all of them, and he was one of the early extreme programming people. He said, pair programming and mob programming enable us to do things faster. And that's been my experience as well. If you have a team who does pair programming or mob programming, they tend to just get things done faster. Similarly, so there are those types of benefits to working collaboratively, specifically pair and mob programming, but other types of collaboration as well, that you get higher quality, more maintainable code faster. Who doesn't want that, right? But there are also a lot of good learning opportunities. If we go to, for this quote, I'm going to go to Robert Martin, also known as Uncle Bob. He is one of the, another one of the Agile Manifesto authors. This comes from his book, Clean Code. He has several. he said the best way to spread knowledge is to work together, to pair, to mob. I think somebody was raising a hand. Someone have a question?
No, I misclicked, sorry.
Oh, okay, no worries at all. I just wanted to make sure that I wasn't like ignoring someone. So, okay, so working collaboratively, I think, should be part of modern software development. Teams should work collaboratively. Teams should also be able to work autonomously. What do I mean by autonomously? So we've talked about the idea of cross-functional teams, where you have all the people on the team, all the people and all the skills on the team needed in order to decide what to build, how that thing should work, actually implement it, verify that it works, deploy it, monitor it, all that sort of stuff. The team should be able to do that whole process, mostly without talking to other teams, mostly just talking to other people inside the team. We want people on a team talking to people inside the team where the communication is easy and the bandwidth is high, and talking infrequently to people outside of the team where the lines of communication are weaker and the bandwidth is lower, right? So we want most of that communication to happen within the team. That's what I mean by autonomous, that for most things that the team doesn't have to communicate with outside teams in order to decide what feature to build, how it's going to work, implement it, all that stuff. Sometimes in order to do that, your architecture may have to change. By architectural, I mean like system code level type architecture, right? There's a, it's called a law. I don't know, you know, in this sort of realm, law is a little bit loosely used. But there's a law called Conway's Law that roughly states your system your system design will tend to mirror your organizational design, and vice versa. So if you have whatever your organization looks like that develops your software, that's what your software system will tend to look like. And if you want to have these cross-functional teams that can work autonomously, your architecture may or may not support that. And if it doesn't support that, you may have to change your architecture in order to be able to support that model. One way that organizations do this is to go to like a microservices type architecture, where each microservice is a set of features that can be worked on and deployed mostly independently from the other microservices. That's one way to do that. It's not the only way to do that, but it is one way. And on the topic of microservices, I wanted to share this quote by Sam Newman. He's the guy who came up with the term microservices and wrote not just the book on microservices, but he wrote 2 books on microservices. This one is called Building Microservices. The other one is called Monolith to Microservices. This is the second one, Monolith to Microservices. He says, if there's only one thing you take out of this book, it should be this: ensure you embrace the concept of independent deployability of your microservices. And now here, his book is about microservices, so that's why he's saying microservices here. But you can think of this in terms of teams, right? Embrace the concept of independent deployability between your teams. Teams can build features and deploy them independently. Get into the habit of releasing changes to a single microservice, or in our slightly wider context, changes to a feature set that an individual team owns into production without having to deploy anything else. From this, many good things will follow. All right. Hopefully, I've offended most people at this point, because we're going to move on from talking about teams to technical things that I think should be included in modern software development. If I haven't offended, if there's somebody who I haven't offended yet, I'm going to go and try one more time to give you your chance to be offended. I think modern software development should include test-driven development. I think most code should be written using test-driven development. Oh man, there's a thumbs up. That doesn't sound like being offended. How is this presentation going to be successful if people are agreeing with what I'm saying instead of being offended by it? So I'm a big fan of test-driven development. test-driven development is, while it has the word test in it, it's not really about the test so much. Really, test-driven development is a technique for decomposing problems into smaller problems and a way to develop code that is higher quality and more maintainable. The fact that you end up with tests at the end is a nice bonus, though. But really, it's about how you design your code more than it is about the tests. You just happen to use tests to do that. That said, these next couple of quotes that I'm going to share are testing related, though. But I just couldn't help myself with this one. This is from Kent Beck, another Agile Manifesto author and an early extreme programming guy. This is from his book, Test-Driven Development by Example. If you want to learn more about test-driven development, this is it's a great book. It was a little bit, like, his writing style is a little bit weird. It was for me, at least anyway, when I was first reading this. But then once I realized, oh, he's writing it like he's sitting next to me and we're looking at code together, then it totally made sense. Anyway, in that book, he says, code that isn't tested doesn't work. This seems to be the safe assumption. What do you do with all those odd error conditions then? Do you have to test them too? Only if you want them to work. So with test-driven development, we tend to have more like lower level tests, like we tend to test discrete components of our code, though it kind of depends on what style of test-driven development you're doing. But the tests that we write as part of test-driven development, while important, are not necessarily the only types of tests that we should write. Modern software development, it's totally valid to have other types of tests as well, as long as they're increasing our confidence in the code. If we need other tests besides the ones that we write using test-driven development to increase our confidence in the code, go for it. Once you get to a point where you're confident in your code, then you don't need any more tests. But you can have other types of tests as well. I didn't put it in this presentation, but if you're interested in this idea of other types of tests and how many of what kind of tests you should use, there's an idea called the testing pyramid that talks about having smaller, low-level tests, having a lot of those, and as tests increase in their scope and complexity, having fewer of those. Anyway, if either go find that, if you're interested in that, go find it, or you can talk to me about it. And I can point you towards some more resources. I also love this one, this quote. This is from Michael Feathers. Oh, if you're in the situation, this is from his book, Working Effectively with Legacy Code. If you're in the situation where you have a code base that has few or no tests and you'd like to increase the test coverage of that code base, go buy this book. Like right now, this is the seminal book for that. Anyway, in this book, Michael Feathers says, code without tests is bad code. I like that one. Hopefully that gave maybe one or two other people a chance to be offended. And overall, like, our goal is not to end up with tests, right? Typically our end users don't care what code coverage percentage we have, for example. We really want to write our tests so we have confidence in our code, so that we're not scared of our code. We're not scared to change our code. We're not scared to deploy our code. And that's why I like this quote, again, going back to Kent Beck, write tests until fear is transformed into boredom. When you have enough tests that you're confident in your code and writing more tests would be boring, then stop. Getting off of my test soapbox for a minute, I think modern software development should be a lot simpler than it is. I don't know how offensive the testing section was. Let me be offensive for just a moment on this one. I'm going to pick on front-end stuff, front-end technologies for a minute. This is not exclusive to front-end technologies. I find that a lot of times we say things like, hey, I'd like a web page. And our immediate solution is, oh, let me install Node and let me install React and I want to use TypeScript so I can have type safety. So I need to have a transpiler. Oh, and then I can't just do CSS. Let me include Tailwind, and now I have to have a processor for that, and I have to have this whole pipeline. When really what I wanted was a web page. Like, can't I just do that? If I just want a web page, can't I just do that with HTML? Sometimes we introduce a lot of complexity that isn't actually necessary to solve the problem we're trying to solve. Now, that said, sometimes we need that extra complexity of the front-end frameworks and transpilers and minifiers and all that. Sometimes we need that, and that's okay. But let's not make our solutions more complicated than they actually need to be. I don't think in modern software development, I don't think we should make our solutions more complicated than they need to be. Because for this one, I wanted to go to a quote by Mary and Tom Poppendick. They're some of the early pioneers in the lean software movement. Mary worked in a like a manufacturing plant for a long time, doing manufacturing and software, and like she kind of and there they were doing lean manufacturing. She kind of pioneered the transition of some of these lean principles from manufacturing to software. Anyway, they have a couple of books. This one is from the book Implementing Lean Software Development. They say the cost of complexity is not linear; it is exponential. So as the complexity goes up, the cost of that complexity does not go up at the same rate; it goes up at a faster rate. That's what they're saying. The cost of complexity is not linear; it's exponential. And the cost of complexity eventually comes to dominate all other costs in most software systems. Complex code is brittle and breaks easily, making it almost impossible to change safely. Wise software development organizations place top priority on keeping the code base simple, clean, and small. So let's not make our solutions more complicated than they actually need to be. One of the ways we can do that is by not chasing what I call the shiny. The shiny is that new front-end framework, that new database technology, that new programming language. That's not to say don't learn new things, but don't adopt new technologies just because they're new. Adopt them because they actually solve part of the problem you're trying to solve, and then they do it better than whatever existing technology you have. On this topic, I have a quote by Fred Brooks. Fred Brooks wrote The Mythical Man Month. He also wrote a paper called No Silver Bullet, which is what this quote is from. And then No Silver Bullet is one of the sections in Mythical Man Month. But so this one actually comes from the paper version. But he said, there's no single development in either technology or management technique which by itself promises even one order of magnitude improvement within a decade in productivity, in reliability, in simplicity. What does that even mean? So he said, there's no single development. There's not one thing that you're going to find in technology or management techniques. So he's talking about like technology. He's talking about frameworks, programming languages, things like that, or management technique. Here I would classify management technique as what we were calling process before. So he's saying you're not going to find one thing in process or in technology which by itself promises even one order of magnitude improvement. An order of magnitude is an exponent, so you're not going to get a 10x improvement by implementing some new technology or some new process. That's what he's saying. Like, you're probably not going to find that one thing that just revolutionizes how all software development is done. It's probably not going to happen. Maybe it will, but it's probably not. A couple more technical things. In modern software development, we should focus on refactoring, not rewriting. Our tendency is to a lot of times is to say, oh, it's just look at new code and say, oh, this is a terrible mess. It's unsalvageable. I'm just going to throw the whole thing away and start over because that's easier than dealing with what we have now. I have some quotes about that. One is from Ron Jeffries. He said, it's always tempting to developers to start over and rewrite. It's almost never the best plan. Instead, get good at refactoring and apply the campground rule. If you're not familiar, the campground rule, I don't know if it's an actual scouting rule, but that's what it's referring to is when scouts go camping somewhere, the campground rule is to leave the campground cleaner than where you found it. So if you go and work on a piece of code, you leave it cleaner than you found it. You don't necessarily clean up everything, but you leave it cleaner than you found it. Another quote from Martin Fowler about refactoring. Martin Fowler is also one of the Agile Manifesto authors. He says, in almost all cases, I'm opposed to setting aside time for refactoring. In my review, refactoring is not an activity you set aside time to do. Refactoring is something you do all the time in little bursts. So rather than having a refactoring sprint or specific refactoring tasks, Martin Fowler is advocating for doing those refactorings in small chunks as part of your normal work. As you work on a piece of code, if it needs to be refactored, also refactored. Excuse me. And then one more quote about refactoring. This one, we're going back to Mary and Tom Poppendick. There we go. They said, probably the biggest mistake we can make is to regard refactoring as a failure to, quote, do it right the first time. Like sometimes we think, oh, we need to refactor this because we didn't do it right the first time. They're saying that's not really what refactoring is. In fact, refactoring is the fundamental enabler of limiting code complexity. We were talking about complexity before, right? Increasing the change tolerance, value, and longevity of the code. Refactoring is like exercise. It is necessary to sustain healthy code. Even the most time-pressed people in the world, executives and presidents, build in time to exercise to maintain their capacity to effectively respond to their next challenge. Similarly, even the most time-pressed developers in the world build in time for refactoring to maintain the capacity of the code base to accommodate change. All right. So that was some technical things that I think should be involved in modern software development. Let's talk about metrics for a minute. This one's a relatively small section. Most of us as software developers, we want to do a good job, right? I believe that that's true. Most of us, want to make good software that provides value to our users. But how do we know if we're doing that, right? One thing that we often go to is some way to measure it, right? Let's come up with some numbers that represent how well we're doing software development. And then if those numbers go up, then that means we're doing better, right? If they go down, then we're doing worse. It makes a lot of sense to me, at least, as a software developer. Metrics can be good and they can be bad. If you want to learn about some of the ways in which metrics can be bad, read this book by Jeremy, I think his last name is pronounced Mueller or Muller, The Tyranny of Metrics. This is a quote from that book. Metrics fixation, so this is, he talks about it a little bit more. Metrics fixation is the seemingly irresistible pressure to measure performance, to publicize it, and to reward it, often in the face of evidence that this just doesn't work very well. Used properly, measurement can be a good thing. So can transparency, but they can also distort, divert, displace, distract, and discourage. While we are bound to live in an age of measurement, we live in an age of mismeasurement, over-measurement, misleading measurement, and counterproductive measurement. This book, The Tyranny of Metrics, is not about the evils of measuring. It is about the unintended negative consequences of trying to substitute standardized measures of performance for personal judgment based on experience. The problem is not measurement, but excessive measurement and inappropriate measurement. Not metrics, but metric fixation. So sometimes there are a lot of reasons why we can have metrics that encourage us to do the wrong thing, that have unintended negative consequences that he talks about here. If you want to go read a bunch of reasons why we can have that, this is a great book. There's some other books that I could recommend, but we shouldn't do that in modern software development. The metrics that I've found in modern software development that I have found most effective come from this book, Accelerate. This is one of the places that actually does have at least some science and data behind it. There are 4 metrics that they talk about in this book that they measured. They talked to companies and evaluated their performance and things like that, and they came up with 4 metrics that actually matter according to their research. The first one is cycle time. We mentioned this a little bit earlier when we were talking about lean software development. Cycle time is how long it takes you from when you start on something to when you get done. That's it. Like how long is that? Is it minutes? Is it hours? Is it days? Is it weeks? Is it years? How long is it? Cycle time. If you measure that, and track that, that can be helpful. Now, just how long something, like if you're finishing things, but they never get to an end user, that's probably not very helpful. So one of the other metrics is deployment frequency. How long are you deploying? Meaning making the things that you're getting done available to end users. You know, like in a web application, this could be deploying your web app, but it could be some other deployment mechanism as well. So cycle time, how long does it take to get something done on average? And how often are you deploying those things? Measure those. Those are the first two metrics that they say actually matter. The third one, you know, if you're getting things done and deploying it, but stuff is breaking all the time, that's probably not good. So the third metric is change failure rate. You're getting things done, you're deploying it. How often, when you're deploying things, are things breaking, right? You can think of this in terms of bugs or rollbacks or something like that. You know, there are different ways to measure it. But how often are things breaking? That's an important measurement. But if you're so paralyzed by fear of failures that you can't actually get anything done or do anything, that's also bad. So, you know, while knowing what your failure rate is, that's important. What is sometimes even more important is what's called your mean time to recovery. Once something is broken, how long does it take you to fix it? So those are the four measurements that they talk about in Accelerate. Those are the four that I have found value in: cycle time, deployment frequency, change failure rate, and mean time to recovery. And that's all I'm going to say about metrics. I don't know if that was offensive enough. Might not have been. For our last section, I wanted to talk about deployments. Deployments with modern software development. I mean, really, if we don't ever deploy anything, then our users won't get any value from it, right? So we have to deploy stuff sometimes. Really, we want to deploy stuff to our users, provide new code, new features to them that hopefully provides value. We want to do that without fear. I don't want to live in fear. I don't want to live in terror every time I go to deploy some code that I wrote. That's my goal with modern software development. I don't want to, when I deploy something, I don't want to be scared. I want it to be a non-event. One of the best ways that I have found to make deploying a non-fear-filled event is to use trunk-based development. So rather than having long-lived branches that diverge for a long period of time from whatever your trunk or master or main or the branch that you're actually deploying, you have at most very short-lived branches, you know, a day or two maybe, or that you do most of your development and commit it directly to your trunk or main or master or whatever that deployment branch is. Going to Jez Humble again, and also Dave Farley, they're the ones who co-authored the continuous delivery book. They said the most important practice for continuous integration to work properly is frequent check-ins to trunk or mainline. You should be checking in your code at least a couple of times a day. Yeah, because if you're not integrating your code changes, you're not actually doing continuous integration, right? Integration means putting the things together. If you're not actually, if your changes are off living in some other branch somewhere for a long period of time, they're not actually integrated. Ideally, in modern software development, I think that we should, that teams, that one of those cross-functional teams that we're talking about, should deploy their changes anywhere from a couple of times a day to every 2 or 3 days. Yeah, and you might be looking at me like, that's terrifying. Oh, you might even be saying, aha, but John, I can't do that because the thing that I have to build will take longer than 3 days. I can't deploy it, can't do it. To which I would say, yes, you can. And the way you do it is with feature flags. So you can separate the deployment process from the release process, right? You can deploy changes, but not actually release them to your customers. And the way you do that is with feature flag. So you can have, say, there's this code out there. It's not actually accessible by anyone because it's behind this feature flag. You know, there's a conditional statement in there that says, is this feature flag on? If not, don't show this piece of functionality. And so I think feature flag should be a part of modern software development. And that's our last thing that I wanted to talk about. So hopefully you had a good opportunity to be offended by at least one of the things that I said. Because if you were, that will put us in this sort of situation, I'm hoping, where, you know, I've said some things, and hopefully, you know, to at least one of those things, you're reacting kind of like the cat over on the right. So I'm going to assume that there's at least one thing that I said here that you disagreed with. And so what should we do about that, right? The way I see it, we have three options. One of your possible options on how to deal with this disagreement is you could just say, John's wrong. Hey, I went to this, you know, tomorrow when you go to work, you're talking to your coworkers about what you did. You can say, hey, I went to this presentation and this crazy guy, John, he said this thing and it was stupid and that can't possibly work. You know, we talked about how our initial reaction when we hear something that we don't agree with is to reject it and potentially even get offended by it. And if that's where you are for some of this stuff, that's okay. It's all right. You know, you take that. You do you. We can still be friends. It's cool. So this is one option. You can just say, you know, that thing that John said, it's wrong. It's wrong. I'm gonna classify it as wrong for now. That's one option you have. Another option is maybe you were like, okay, John said this thing, and oh, my computer's doing weird stuff. Okay, John said this thing, and maybe there's something there. I'm not sure, but I want to learn more about it to see if maybe there's something there. Maybe it's just crazy, but maybe there's something there. That's another option. That's option two. And of course, the third option is maybe I was just right. I was just right the whole time. That is also a possible option. So those are some options that you have for how to deal with this information. Maybe I was just wrong. Maybe there's something there, or maybe I was right. If you're in one of those latter two categories of maybe there's something there, or, you know, maybe some of the stuff that I said you weren't familiar with, and you're like, yes, this is the thing. This is what I've been searching for. Thank you for saying this. How can I know more about this? For people in those latter two categories, here's a list of stuff to follow up on. So I shared a lot of quotes from people who I believe are industry experts. I think this list is all the books that I provided quotes from, and also a link to that Mega Man quote site again, if you want to find more of that, you know, more quotes. There are a bunch of authors on there that I didn't share quotes from as well. But there are a lot of other good books as well. This is if that first list, if you just didn't get enough from that first list and you need more, here's a list of even more books that I would recommend. So hopefully this was interesting to you. Hopefully I offended everyone, at least on one thing. And if you want, again, like I said, if you want to talk to me about follow up on any of these things, feel free to email me or message me on LinkedIn. Even if it's just to say, hey, John, you were totally wrong on this. Yeah, and with that, that's all I have.
Awesome. Thanks, John. We are going to go to Gary. Gary's going to give us surprises, or do I have some slides I need to show first? I have some slides I need to show first. I never remember it, and I always get that wrong.